So want to learn more about the electrocoagulation because it's a very naive word to most people. I would think if as David told me, he ran across it and he's like, this is witchcraft. This is a witchcraft word. And he said coincidentally someone called him up the same week and you should check this out. It was a coincidence of fate. Um, can you kind of explain to me the process, the writer's part in it?
So I would be happy to. So Dave, representing Round Mountain Waters, and in his town, there's a person used to teach at Red Rocks Community College, Yarrow. And Red Rocks Community College is the leading water treatment operator school in the state, second in the nation. And they actually have a little electrocoagulation unit there. You can go and you can see it. Basically, it's just metal plates parallel. You put electrons through water and a metal plate. That's electrocoagulation. And where that surface of the electron and the water meet, you have a reaction. And for example, it will take arsenic ion that stays in the water. It's got a charge, so it'll stay in the water like a magnet on your fridge forever. When you put that charge through it there at the metal plate, it will turn it into a oxide form, which is like a rock, and then it'll settle out. And so you actually convert that hazardous waste back to its original form in the ore that it was mined from. So that's the basic process of electrocoagulation.
Okay, so how long do a set of plates last?
Typically, they dissolve at about 0.2 pounds per 1,000 gallons treated. You put in as much electricity as you want to dissolve the plates, so you can dose it like you would chemically. 0.2 pounds of iron is about 25 parts per million of ferrous sulfate.
In one of the sites, like in Oklahoma, they replace the blades every 6 months. And that's for permitted flow of 100,000 gallons per day. The trick is not to have to replace them all at once. You go every week and check them. And then some will wear quicker than others. And so you take them out a little at a time. Every week you go through and take out a few and put in a few new ones. So it's kind of a continuous thing, but average, if you just leave them about 6 months, if you're running hydrocarbons out in the oil fields, they probably go a little quicker and than that, if there's more burden in it. So it varies depending on what you're running through the system.
So it's sort of like a thermostat on your wall. If you need more stuff taken out, you just turn up the electricity going through. And if you need less, you turn it down. It's current controlled, so it basically measures the ions in the water because that's what conducts the water through the water is the ion. So if there's more there, more electricity flows through. If there's less there, it doesn't have the conductivity and doesn't draw the electron through the water.
So when it reacts with the metal in the water, it creates a new solid that dissolves out. Does how many pounds per week are we talking at 100,000 gallons a day?
So that is an excellent question. The United States EPA says electric coagulation as compared to alum coagulation, chemical, you have 83% less solids and it filters 76% faster. So you have 83% less solids with electrocoagulation versus chemical coagulation. And the primary reason for that is chemical coagulation makes a hydroxide flock that holds water, whereas electrocoagulation makes an oxide flock that doesn't have a charge on it, so it doesn't hold water. Therefore, the water passes through it.
Oh, that's really interesting. So you're actually putting more of the water just straight back, and what dissolves out is not as wet, or I don't know. Maybe I'm not sure.
It dries faster because it is in an oxide form. For example, people can relate to a diaper that you put on a child, and this diaper is there, and it's got some polymers in it. And when the water comes in, the polymer absorbs the water and takes it away from the child. Then you take that diaper, now it's got the polymer in, it's wet. If you were to set it in the corner, it would stay wet for 6 months because it holds the water. That's what it's designed to.
Gotcha.
With electrocoagulation, you coagulate it, you filter it out, and you can literally watch it dry and crack in, well, in a few hours.
Yeah, in a municipal application of a town of 1,000, basically, we run through the machine. It comes out of the machine and it's kind of a slurry. You can dip it with a cup and the solids will settle and the water comes to the top almost immediately. So you know exactly where you're at, how much electricity you need to add, or if you need more time in the chamber. When it comes through that, once you get that right, we get in a town of 1,000, we get about 10 pounds a day of solids, 2 5-gallon buckets. And we run it out into a drying bed. It cracks immediately and dries up. And they, no equipment, they take a shovel and shovel it in a bucket. They actually put it in their dumpster and it's gone. So that's because we've taken so much of the solid and the bad stuff out in the lagoons. We don't have that many solids left. And we have the PSSs are always below detect, and the BODs are typically all down. Through a lagoon, we get typically 2 to 3, less than that sometimes. All the biologics are gone, fecals, E. coli, they're gone. Below detect always. And so that guy gives you an idea. Very efficient to run it, and they can do it with one guy. You asked about licensing, by the way, back there. If we don't have the EC on the end of it, sometimes we don't. We're just running lagoons. Basically, you can run it with a Class C license. Typically, that's not hard to get. If we add the EC, sometimes the states will want us to do a Class B operator. And of course, that you have to have a little more sophisticated guy. They have to have some time served before they get a license. So it's fairly simple along those lines as well.